Okay, so thank you for coming. I don't know who else is going to join us, but that's totally fine. We are going to review for the test that you are taking next week for geometry. Now, there are three main standards that you need to know for this test. And I know some kids are going to get frustrated because they're thinking that proofs are going to be on the test, and proofs are not going to be on the test. So that is a little bit of a sigh of relief. Now, knowing things about triangles will be on the test, and that's what we're going to be paying more attention to. Freddie, you realize I can watch you from behind me. So the main AKS that we're going to be doing is these here. Your test is on AKS 8, 9, and 10 right here. And AKS 8 really focuses on understanding descriptions of geometry terms. So it's kind of like we have side, angle, side, 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 but why does that happen? Does it happen because it's a translation? Does it happen because it's a reflection? So that's what that AKS is talking about, is why is something occurring? What transformation happened for it to occur? AKS 9 right here talks about, okay, if two or triangles are congruent, then they're congruent, but their corresponding parts are congruent. And we're going to talk more about what that means. But for example, if I have triangle ABC is going to be congruent to triangle DEF, and I have to make sure that everything matches up. So if I have triangle ABC being congruent to triangle DEF, I have to make sure that A maps to D, B maps to E, and C maps to F. So that's kind of the whole thought process behind that. And then lastly, of course, knowing the different types of triangle congruence. Now, we already know from the song, if you're in my class, that we watched yesterday, like side, angle, side, 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 angle, side, angle, 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 side. Anyway, the last one, of course, is a hypotenuse leg, and SSA is the one that we're not going to be using. I have no idea what he's doing. But that's kind of like the premise of what's going on. So those are the AKS that we're covering. Notice nothing there says anything about proofs. Proofs really should not be on your test. Let me just go ahead and pull this up on the screen though. Okay, so first things first, this is kind of what we look at to see. Why are you you're not even photobombing. You're like photo distracting. Stop. The whole thing is there, Freddie. I'm sorry. Go away. Anyway, none of you are going to learn any triangle symmetry because of this kid behind me. Stop. All right, these are called achievement level descriptors. This is how we know that you've mastered the content. So by the end of the unit, we want you to be able to do these things. We want you to know about transformations. We want you to be able to analyze congruent statements. And we want you to, this last part you're not going to learn to unit 5, but prove statements congruent. Also, understanding ideas about rigid motion, which we've talked about already, translations, rotations, and reflections. And then also the proving the theorems, which won't be on this test, and then some constructions that you're going to learn for Unit 2C. All right, so let's kind of get started and look at our first question that we've got going on here. This is an example of that AKS, which talks about everything being preserved. Okay, and before I keep going, let me just make sure no one else wants to log in. I can still see you. There we go. There's another person. Welcome, welcome, Penguin. All right, so let's take a look at our first question. If you're just signing on, you'll see Freddie photobombing and dancing behind me because he's 8 years old and can't help himself. All right, so we've got triangle ABC after a transformation on the y-axis, a reflection of the y-axis, which is not preserved. So again, we're looking at rigid motion. So what are some things that we know about rigid motion? We know that with rigid motion, we're talking about distance, angle measure, is absolutely 100% preserved. And because distance and angle measure is preserved, if I have this triangle here, yay, we have another person. Admit. If I have this triangle here, I need to make sure that because the distance is preserved, other things are also preserved. Not only is distance preserved, but if this is, let's say, 5, 6, and 7, it's not. We're going to use our imagination, 5, 6, and 7. We know that no matter what, this is all going to work out because the area has to be the same, because we could still do the area formula, which is 1/2 base times height. So we could do this area formula, do 1/2 5 times 6 for this triangle here. That's going to give us half of 30, which is 15. That same formula done here, 1/2 5 times 6 here, is also going to give us 15. So area is preserved. To find out the perimeter of a shape, we add up all the sides. Well, if we add up 5 plus 6, that's 11. 11 plus 7 is a smiley face, 18. So we know that if we did the perimeter here, we'd get 18. And if we did the perimeter here, we'd get 18. So because the distance measure is preserved and because the angle measure is preserved, that's why we know that perimeter also has to be preserved and area has to be preserved. Also, we're not going to deal with anything changing until we get to similarity. That's really going to be the big shift, is when we go back and forth from there. So the main things to think about here is when you have it. Also, we have to remember mapping. So A is going to map to A prime, B to B prime, and C to C prime. So those are the other main components. In this case, if we have a reflection on the y-axis, so like here's our triangle, here's the y-axis, and we have our reflection, something called collinearity, which you really don't even need to know, but I pulled up on purpose because I wanted to talk about this type of question, is what is not preserved. Everything else is preserved. The triangle is going to stay the same way. Distance is always preserved with rigid motion, as is angle measure. I think he left. Yay. Okay, next question. And if you have any questions, feel free to type it out, or you can put your microphone on and ask. That's totally fine also. All right, next that we've got going on is, there we go. Now we've got if triangle W prime, X prime, and Y prime is the image of triangle WXY after a rotation of 90 degrees, which statement is false? And again, this goes back to what that AKS is. That AKS says we have to make sure that when we have our shapes, they map perfectly over. So let's draw it. And this test is like super easy. I think it's like 10 questions. So like nothing insane. It's going to be a lot less stressful than the previous test you took. So we've got WXY. Because this is just a sketch, it doesn't matter where we write the first one, as long as when we write our image from our pre-image, that everything maps perfectly. That's what we really want to know. So let's take a look. I'm going to switch some colors here. So we've got which statement is false. So we're looking, really, 3 of them have to be true. So does XY, well, here's XY right here. Does that map to this? Yes. Now, I will say, technically speaking, this set a rotation of 90 degrees. Now, I didn't draw a rotation, I drew a translation. But because translations and rotations and reflections are all isometries, coming up with the corresponding parts, that's not going to make a difference. So that's why it's fine that I drew a translation. But yes, I did notice I drew a translation instead of a rotation. Okay, so anyway, that is true. So XY is going to map onto X prime, Y prime, so that's not it. Okay, this one says WX is going to be parallel to W prime, X prime. So if we do this, here's WX. Pretend I drew that straight. And yes, woohoo, we have parallel lines. That's part of the whole point of it. Oh, actually, that is going to be false because it is a rotation. I just caught that. That's the one that they want us to do. Because if we do a rotation, I was thinking it wouldn't have made a difference, and it really wouldn't have made a difference, except I didn't notice the parallel line. So let's do this again. Here's our WXY. If we rotate it 90 degrees, it's going to go like this-ish. WXY. And so again, we are still going to have, these are going to be the same. They're going to be the same because of preserving distance, but we will not have it as parallel lines, because here's WX like this. And then with our rotation, W prime, X prime is going to intersect. So the correct answer is choice 2, because choice 2 is wrong. The other ones make sense, and we can double check. Let's look at the order. Here we have WXY here. And then up here we have W prime, X prime, Y prime. So we can see that all of this maps perfectly to each self. Same thing with XY, as the angle, mapping to XWY. Again, X to X prime, W to W prime, Y to Y prime. So all of that maps perfectly. Your test will try to trick you. You have to make sure that you have your points map completely. That's the whole part of what AKS 9 is that I talked about up here. Okay, AKS 9 says, can you show it only if those corresponding pairs of sides and angles are congruent? So you have to make sure that you know the corresponding parts. All right, moving on. If ABC is mapped to DEF after a line reflection, so first let's just figure it out. Here's ABC. We have a line reflection. It doesn't matter what line reflection you do, but we know that that maps to DEF, like that, DEF. And then DEF is now mapped to XYZ after a translation. So I'm just going to make XYZ down here. And then what's the relationship between ABC and XYZ? Well, because the only rigid motions that happen were reflections, which is a rigid motion, and a translation, which is a rigid motion, we know that the shapes have to be congruent. So immediately we can eliminate choice 3 and choice 4. And then we have congruent and similar, and congruent but not similar. If something is congruent, you are guaranteed it's going to be similar. So the answer to this is choice 1. I don't think you're going to see anything with similarity on this test. However, I do suspect that you are going to see needing to know the congruent pieces. So if multiple transformations happen, what can be said from there? So that's definitely at least one of the questions on your test, because that matches the AKS. All right, next. Quadrilateral MNOP is a trapezoid with MN and OP being parallel. So here, let's just sketch it. If there is no picture, please just sketch it out. Oops, and this is wrong. This is P and this is O. So we've got MNOP, and the order does matter because whenever we label quadrilaterals, we have to make sure we go in a circle. So that means that we have our M. We have our M, N, O-P. Okay, welcome. Just go ahead and turn off your microphone, honey. Okay, so we've got our MNOP, and then it says that if that's the image after a reflection over the x-axis. So we know the x-axis goes across like this. You can just mute your microphone, honey. Sorry. It's okay. Do you know how to mute it? You should see like a little, there you Okay, let me show you in a second. No big deal. So you should see right over your face, you should see like a little, like a button like this, that you can mute your microphone. And then right here, you can turn off your camera. Where? On the bottom, like underneath your head, you should see like a microphone, or you might see it over your face. Okay, I'm going to mute you I'll mute you for you. You're good. I just muted you. You're fine. Okay, let me go back. And here we go. Okay, perfect. Okay, so back to here, we've got MNOP, and then we have that reflection happening over the x-axis. Which two sides of quadrilateral M prime, N prime, O prime, and P prime are parallel? This again is checking out that AKS number 9, which talks about, do you know the corresponding parts? Because it tells us that M has to be parallel here, we know it just has to match up. MN is parallel to OP. So that means that M prime N prime has to be parallel to O prime P prime. That's all this AKS is saying. Do you know to map up the points? So here we've got MN. Well, that's right, M prime N prime and O prime P prime. So it's choice 1. Here it says MN. So that's this one. And NO. That's clearly not the correct answer. Here it says PM for choice 3. It says PM and OP. Well, that doesn't match up. And again, the MPM and the NO. So you have to make sure that everything matches up. That's the most important thing. Does it map on? Do the letters map up perfectly? If they do, then that's most likely the correct answer. All right, now we're going to shift it. I think this might be our last one. We've got, as shown in the diagram below, when the right triangle DAB is reflected over the x-axis, the image becomes DCB. So this is our pre-image, our DAB is our pre-image right here. And then we have the reflection. So which statement justifies AB is congruent to CB? So why is this line right here congruent to this line? And this is where they're going to try to trick you, because they're going to tell you other things that are also accurate. And because they're going to tell you other things that are also accurate, you might be like, oh, that's it. So let's take a look. Which statement justifies why AB is congruent? Well, distance is preserved under reflection. That is true. Okay. Orientation is preserved under reflection. Orientation we didn't talk about too much, but if we think about orientation, let's take a look at my water bottle one more time. Here, my cap is up. If I reflected it over my hand, the cap is now pointing down. So that means the orientation is not preserved. Points on the line of reflection, main invariant. You haven't really learned about invariant, so don't worry about that. And right angles remain congruent. And this is the one I wanted you to see. The answer is choice 1 because it deals with side measure. But this is the one I wanted you to see because, yes, right angles remain congruent over reflection. Why? Because reflections are examples of rigid motion. And because reflections are examples of rigid motion, angles are preserved. So that's true. But right angles have nothing to do with AB being congruent to CB. So sometimes you just have to read the question a little bit more clear, because in this case, let's say the answer choices were randomized, you might have seen right angles remain congruent and be like, oh, I got this right. And you would have gotten it wrong. So just make sure I put this question up here just so you can think about paying attention to the problem, because I don't want you to mess it just for no reason. Where is my mouse? There you are. Okay, next. Okay. Oh, more. Everyone better get all the AKS 9 right, because we have a lot of AKS 9 questions. Okay, after a counterclockwise rotation about point X, scaling triangle ABC maps onto RST. So again, this is AKS 9, which talks about how do things match up? What are the corresponding parts? Right away, because it tells you ABC, I just say this, write down ABC. It tells you it maps to RST, so I'm going to just match it up, because now I know A has to map to R, B has to map to S, and C has to map to T. Anytime it tells you with mapping, corresponding parts or anything, the letters have to match perfectly. A, B, C, R, S, T. So which statement must be true? Angle A maps to angle R. Yep, duh, that's exactly what it is, the first one. But let's just double check it's not the second one. A maps to S. Well, that doesn't make sense. Here's the A, here's the S, so it can't be that one. CB, so if we do CB, this is our first one here. CB, this would be our first one. Here's our second one. That maps to TR. Well, here's our first one. Here's our second one. That doesn't map up, so it's not going to be choice 3. And then choice 4, which says CA, so here's our first one, here's our second one, maps to CTS, here's our first one, here's our second one, and nope, that doesn't map. So again, AKS 9 is literally, do you know how to map questions? That's it. If you know how to map questions, you literally will master AKS number 9. Let's take a look at the next section. So the next section of the AKS, again, is do you know the triangle congruence theorems? And I have already sang it for you, but we'll sing it together at home. I know you're so excited. I feel like turning on everybody's mic so you can sing with me. But we're going to do our lovely song from our first video on YouTube. Ready? So it goes side, angle, side, 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 angle, side, angle, 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 side. That was off, but you know what it is. And then remember the other one is hypotenuse leg. And the last one, of course, is you would never do side, side, angle or angle, angle, angle. So when you talk about this, we've got our side, side, side. Side, side, side is actually one of the easiest because you just have to make sure that things map up. So here we have our SR on line 1. So here's our UT. And then we've got 2 here and 3 here. So we could write triangle SRW is congruent to triangle UTVY because of side, side, side. We have 3 sets of matching sides. For side, angle, side, the most important thing here is your angle has to be sandwiched between the 2 sides. So when we talked about in class, I had talked to you about no offense to school lunches, and I love our cafeteria workers, but there's a difference between getting a chicken sandwich from Zaxby's and getting a chicken biscuit in the morning from school. In school, we have our bread, chicken. Bread, chicken. Okay? We will use this random piece of plastic. Bread, chicken. Chicken on top. So the 2 sides and the angles on the side. When we go to get Zaxby's or Chick-fil-A, our chicken is mapped and stuck between our 2 pieces of bread. That's what side, angle, side is. When you have side, angle, side, you have to remember the angle has to touch the 2 pieces of bread. That's what this is. Same thing for angle, angle, side versus angle, side, angle. When it says angle, side, angle, that side, the angles are the bread, and that chicken's got to be in between the bread. Angle, side, angle. If it isn't, then it's going to be like this. Here's our 2 angles. There's our bread. Here's our chicken flying on its side. So we have to make sure that we have the right location. Next, hypotenuse leg. Hypotenuse leg happens when you have right angles going on. So for the right angles, it won't always be hypotenuse leg, but if you have a right angle, then if you have one of the hypotenuses, like one of the longest side is the hypotenuse, and then you have any of the other sides, then you have hypotenuse leg. The reason why you have to have a right angle is because hypotenuse, when you have a right triangle, you can do a theorem that you're going to learn in December called the Pythagorean Theorem. And when you do that, that's going to give you a squared plus b squared equals c squared. And you can solve for the third side. So it's kind of like you're doing side, side, side. And that's kind of why hypotenuse leg works. So let's take a look at some. Here we've got triangles here, and we can see very clearly that this has 1 line on it. Right here, 1 line. This has 1 line. This has 2 lines, 2 lines, and this has 3 lines. So these are going to map up onto each other because of side, side, side. Now, technically speaking, if we wanted to, we could have also addressed this angle here. So we could have done, if this whole thing was given, these images, we could easily have done side, angle, side like this. Also, we could prove it by, because they gave us this right angle, we could prove it by hypotenuse leg. Or, I mean, there's so many ways you could prove it, but those triangles are definitely congruent. And our letters, since it would go, here's our O, here's our P, so P would go here. G is the right angle, so R would have to be the right angle, and D is this top angle, so C would have to be the top angle there. Next, let's take a look here. Again, we have our 3 sides. Notice how R is the first letter said. R is the first said letter said, and R is located between the 2 and the 3. So here's our 2 congruent line. Here's our 3 congruent line. So we know our first letter is going to be O. Then we have to find A. A comes next, it's second. A is located between 1 and 3. 1, 3. So we know E has to come next. And then we know G will be the last one. So basically, again, the corresponding parts. Real quick down here, you won't see this. This is actually similarity. It's not congruence. So you're not going to see this coming up. Hold on one second. Yes, that triangle is side, side, side. Great question. It's side, side, side because we have the 3 sets of sides and there's no angles that are referenced. Perfect. Well done, No Name. Okay, moving on. We have here, we've got, again, this triangle is the same triangle up here, so I'm not going to describe it. Literally, hypotenuse leg would work, side, side, side would work, side angle side would work, everything would work. But let's just map it out. L is our outside, so it's going to have to match to E. Also, notice that our L had 2 curvy lines. So that means that it has to map to the angle that's got the 2 curvy lines. So that's why we can put E here. And then it tells you I comes next. I's got that one little curve right here. And so that's going to map to A. And then we have our last one is going to go there. So any triangle that has a right triangle can be a leg. Yes. Anytime you have a right triangle, and we're going to get more into this coming up, this is going to be always the hypotenuse. The hypotenuse is always the side that's opposite the right angle. The other 2 sides of the triangle are called legs, and that's exclusive to right triangles. The hypotenuse only exists when you have right triangles or 90-degree angles. So that's why you have to have the longest side, which is opposite that right angle, and then either of the other legs work. Because, and this is not at all for your test, this is coming up much later. Sure, I can do another example of hypotenuse leg or any of them. Here coming up, you're going to learn how to find the missing side. Yep, I got you. I got plenty more coming. And then here again with the FOX, let's just do the mapping. F has 3 lines, B has 3 lines, so B has to be next. Then it says do the O. This O has 2 lines, so we have to get the one that has 2 lines. This X has 1 line. This O has 1 line, so that's how it has to map. So it won't always be perfect letters. You have to see what are the congruent parts. Okay, let's look again at the corresponding parts here. Okay, oh, that's right. I wanted us to play a Kahoot. Anyone interested in playing a Kahoot? Because that's what I was going to have us do to do this. Yes, no? This is what I wanted us to do. Okay, cool. Classic mode. Oh, I didn't even... Oh my gosh, that's loud. Okay, hold on. I want to make sure that I change the mode real quick. Aim generator off. Oh no, we're good. Okay, go ahead, log in to the Kahoot. We have 1 person. No names back. Love it. I think there's 1 more person. We'll wait. All right, we're going to start, but then log in if you want to. And I just want to talk as we go. So if there's any time we need to stop, we can stop. Here comes our first question. Okay, so let's look at this. If we have here because it has this one line, this gives us an angle. Here's our one angle here, angle. Then we have this line for our side. And then here we have two lines for our other angle. So this gives us angle, side, angle, and it makes the sandwich. So that's why it is yes for angle, side, angle. We would need two sides for it to be side, angle, side. Oh, next. Good. Let's take a look. So it's kind of invisible, but we can see that there's one line here and one line here. So that gives us our side. We have a curvy angle here and a curvy angle here. That's going to give us our angle. And then we have two lines here. So that's going to give us our other side. So now we have side, angle, and then side for this. Okay. It's all right. By the time we'll get there. No big deal by the time it's done. Yay, we're getting better. So let's take a look real quick. Here we have a side with one line. Here's another side that has two lines. And here's our third side with three lines. So this makes it side, side, side. Theo is in the lead. Are these triangles congruent? Make a guess. 3 seconds left. No is correct because they didn't tell us anything about a line being congruent or parallel lines. The only thing that we could technically know is we know that these angles are congruent because they're vertical angles. But that's the only piece of information we know, and we know we need at least 3 things in order for us to have triangle congruence. Hypotenuse leg is the only one that you technically only need 2 for, but then again, you have the right angle as the third one. Ooh, this is a good one. Okay, angle, side, angle. Let's take a look. Here is our first angle that maps. The blue maps to the blue. We know also that the orange is going to map to the orange. So we have our 2 angles. This side right here, we have because of the reflexive property. So if we just pull this one triangle out, we can see that we have our angle is here and our side is inside. What kids mess up with here is they see these arrows and they think that the arrows mean congruent, when in fact the arrows mean parallel. And that allows us to have those inscribed angles. Okay, this is hypotenuse leg. First, we see that it has a right angle. So because it has a right angle, we know that it could be angle, side, angle. Like if we had this side here, we could have do side, angle, side. So that would have been possible if we had both legs. But we don't have both legs. Here we have one side. Here we have another side. And then we have this. So some kids, I'm glad, would have put SSA, but they would be wrong because that just spells a bad word backwards. So that's why, because we have the right angle, we know this is the hypotenuse. It's the longest side that's opposite the right angle. And then we have any other side. And that gives us hypotenuse leg. Oops. Are these triangles congruent? Yay! Our first victory. Again, if we look here, we have a side to side, angle, angle, and then the other side. Whoa! Shake up, shake up. I was hoping we would get this one wrong. I wasn't expecting everybody to get it wrong, but let's just take a look. We do have the right angle, so that's good. Trick question. All they gave you was one leg. So there's no theorem that's just leg. So, or angle side, and there's no theorem that's just angle side. So that's why it's none on this one. Okay, let's see here. It is side, side, side. It's side, side, side because we have these sides match up. These sides match up. So that's our two sides. And then we have the reflexive property in the middle as our last one. So side, side, side. We'll get there. Don't worry. This is still new. It's okay. That's extremely unhelpful. There's the picture. I don't know if you can see it. It's blue. It's blue. Just click blue. It's hypotenuse leg. Yay! Let's see if they'll show us the whole media. So if I drag it, you can kind of see it by my face, but you can see on the bottom it's got the right angle and then the reflexive property for the other line. Ignore you? Oh my goodness, this was a wipeout. Let's take a look. Here we have our angle. One line maps to this. Angle. One line. Here we have another angle. Maps to this angle. Let's take a look at where the side is. Here's the side. Here's our chicken. Is our chicken between our two angles? No. So because our chicken is not between our bread, it's angle, angle, side, not side, angle, side. They can see you even though you can't see you. It's just how it is. Okay. Almost done. Two more. Okay. I will go over that one more time. Oh, here it is all over again. See how you have the two angles? This is angle, angle, side again, Woo! Yep, let's look at it so we can see it. That is awful. Here we have one line. This one line right here. Here's our angle. That maps to this one angle here. Angle. Then we've got our blue, or I guess I hit pink. Here's our other angle. So we know for a fact we have two angles. The issue is where is the location of the other side? If our other side was right here, and it would be touching both of these angles, that would be angle side angle. Because we've got our angle, it's touching the side, and then we have our other angle. In this problem, this is where our other side is. So it's only touching one of these angles. So because it's only touching one of the angles, it has to be angle, angle, and then the side. The S is not in the middle because the S, the side, is not touching the other two angles. We can do another Kahoot. I think there's one more question left on this Kahoot, and then I can look for another one. And then I just realized there's one more thing I have to show you that I missed. Oh, that's unhelpful. Yay! Side angle, because if you do it backwards, it's a bad word. Okay, so yay! All of you win because there's only 3 people participating. Woohoo! Okay, does anyone else want to do a Kahoot? I just X'd out of the whole thing. That stinks a doodle doos. Okay. Let's find one. I had one before that I was going to save for class, but we can look at it now. There we go. Math is cool. Fun. Hi. Here, I'll let you change your name just in case you don't want it to be that. And if you want it to be that, you can put it back in again. Okay. Oh, Theo, get back in. I knocked you out. Okay. We are kind of learning something new tomorrow. We're going to do an activity where we won't do all 20 questions. We're going to be doing an activity. I can pull it up and show you where you're going to practice drawing these triangles, doing side angle, side, things like that. Yay! Victory! Cool. Maybe we can go faster. You guys are killing it. Yay! 3 in a row. Where's my mouse? Come on, mouse. You really don't need the bottom part. Awesome. Again, that side was between the two angles. Way to go. Good. That is angle, side, angle, because we have our angles are the one, our side is in between, and then we have the other angles. That's perfect. Okay, this is side, angle, side. It's side, angle, side because here is our one side, here's our other side, and here's our angle in the middle. So we've got S, A, S. This one, you do have the two angles. So those top two angles are congruent. And then you have the two inside ones. And then you have the reflexive line. So you're just thinking angle, side, angle. Excellent. That's angle, angle, side because the congruent side wasn't between the two angles. Yep. Man, this is a bad Kahoot. Okay, so you've got those angles there again at the top and bottom, and then you have the congruent sides, and then you have to figure out about the missing angles in the middle. I think this might be our last question because this one isn't very good. Yep, again, that was the angle, side, angle. So yay, good job. Regarding what we're doing tomorrow, this is the worksheet you're going to do tomorrow. You're going to go to this website, and I did this last year with my students and they really seem to like it. It's actually is one of the things that's created by the NCTM, the National Council of Teachers of Mathematics. And my computer doesn't want to load it. Oh, that's unhelpful. There it is. Oh, apparently I need a plug-in. But anyway, you're going to be designing triangles. So very similar to what we did today, but you're going to be doing it instead with creating your own triangles. And this is still not going to let me do it. Let's try one more time. And last year, the kids really seemed to like it because it helped to strengthen their understanding of the angle, side, angle, and the side, angle, side. So hopefully you like it. And then there's also going to be a delta math to just like reinforce this. So again, well, that's weird. Allow once. It works on the school computer, so I don't know why my computer is so persnickety. Here it is. So what you're going to do is you're going to fill out this spreadsheet, and you're going to pick and create 15 of your own triangles. And then you're going to mark them down and then write down the relationships and see if it's congruent or not. So for example, you might pick these two angles and the side, and see how this says letter C. Well, that doesn't help us very much. So we're going to make sure this B goes on top of this B. And then we have to turn the angle and then see how these angles extend forever. So we're going to have to put this angle somewhere on there and then turn it so it maps to B. And then we have to make this into a triangle. So we're going to end up scooching this baby down. And then we have a triangle. So now we have 2 angles and a side. So then we're going to build another one. We're going to map V onto V. Rotate it. And then we're going to map U onto this line. Rotate it. And then say, are these triangles congruent? And then you can flip it and move it around and see if indeed they're congruent or not. And then that's pretty much it. Yes, they're congruent. And then up here it tells you angle, angle, side. So that is what you're doing tomorrow, is you're going to be creating that. Yes, for a grade. Okay, so that is pretty much what I wanted to cover today. There is 1 or 2 questions I didn't cover, but we'll talk more about them in class on Monday. I don't want to stress you out, but the main thing for this test is, do you know side, angle, side, angle, side, angle, side, side, angle? Let me go back to the presentation real quick. So do you know here, do you know the transformations? Do you know that you're talking about translations, rotations, reflections? Do you remember like you can get congruent parts? Again, number AKS 9 is knowing that the letters match up to each other. And then the 10th one being the angle, side, angle, things like that. Oh no, all of that you're doing on the computer. So we're going to be in the computer lab tomorrow. We're going to be in, I think, A109. I'll post it on the door. So you'll be able to do all of it, but from the computer in the computer lab. All right. I will see you guys in school tomorrow. If you have any questions, talk to me tomorrow at school and we'll take care of it. And thank you for spending some of your Wednesday night with me and for putting up with Freddie in the back. So, anyone else have questions? Are we good? Good. All right. Bye guys. See you later.